Here in example 3, we are working with two circular gears. And we can look at the picture and we can tell that we know the radius for each of these gears. The smaller gear has a radius of 2.5 centimeters and the larger gear has a radius of 4.8 centimeters. We are told that the gears are adjusted so that the smaller gear drives the larger one. So the smaller gear would be attached to the motor and will actually move and will turn the larger gear with it. If the smaller gear rotates through an angle of 225 degrees, so let's go ahead and mark off what 225 degrees would look like. So it turns through a central angle of 225, and as it goes through that angle, there's an arc length that we can measure for that angle as well on the gear. So a point on the gear would move from here, let's say, all the way to here as we move or rotate through 225 degrees. We're going to call this arc length S. Now as the smaller gear moves, the larger gear also moves. It's being driven by the smaller gear. The arc length at a point on this gear would move would be exactly the same as the arc length of the smaller gear. So these arc lengths that we're measuring off will be the same. So what we want to know is, what is this angle that the larger gear would move through in degrees? So let's find the arc length here of the smaller gear. So we have S is equal to R, which is 2.5 centimeters, times our angle, theta. Now for the smaller gear we have 225 degrees. And remember that we want to convert to radians, so I will multiply by pi times 180. And that's what I'm going to put into my formula. So we have our radius, and now we want theta, and we're going to go ahead and use the conversion here, 225 times pi divided by 180. Now we're going to put this into our calculator all at once, and once again we're going to multiply the top all the way across the top. I would recommend putting that in parentheses, and then divide by 180. So I get approximately, and I'm going to use as many decimal places here as I can, and I'm going to leave that into my calculator so that I get the most accurate answer possible. So I don't want to round until the very end. So this is all the information we have for our smaller gear. Now what about the larger gear? Well, now for the larger gear, we actually know that the arc length that is moved is 9.81747, etc. So let's go ahead and say that we know the arc length. We know the radius is 4.8. And now what we're looking for is our angle theta. And eventually we do want to get 2 degrees, but for now we're going to solve for our angle theta in radians. So we know that S is equal to R theta, and our S is already in our calculator. We're going to leave it in our calculators, saves time there, and we're going to solve our equation here for theta. So plugging in our information for S and for R, we're going to divide both sides of our equation by R. So that value that you left in your calculator, now we're going to divide that by 4.8. But when I look back up to what my question is asking me, let's go back up for a second. My question says, through how many degrees will the larger gear rotate? So I'm in radians right now, and I want to be in degrees. So let's convert our answer from radians to degrees. So what do I need to multiply by to get from this radian measure to degree measure? And once again, we're going to leave that in our calculator. We're not going to do any rounding until the very end. And I'm going to multiply this by 180 divided by pi. So we're just going to multiply the value that's already in our calculator, the 2.0 radians, and we're going to multiply that by 180. And then we're going to come in and divide by pi. And we're going to go ahead and round to the nearest whole degree. And I get 117 degrees when I round. So we want to make sure that we give our answer in the units that was requested.